And I kind of feel like our acceleration value is still a little high. Kind of feel like the T-Rex still speeds up too fast. Let me go into the T-Rex class and optimize that. Where is it? There. Acceleration, pixels per second per second. Maybe let's say instead of 5, let's say 3. And I'm just going to check if that checks out. I just want to make sure that it still accelerates at an acceptable pace. Oh, stupid. But I think it does. And you can always change that value, play with it, and adjust it to your liking. Okay, so it works, but I feel like the score, we get points way too fast. Maybe not way too fast, but a little too fast. So let's go into the Scoreboard class here. And we're almost done with the game. There's just one more thing that we need to implement before I think we're done. And that would be the high score. But let me just optimize this first here. Here, the score increment multiplier. Constant here in the Scoreboard class. Let me just, maybe let's cut that in half. Let me check it. Yeah, and I think it's much smoother than it was before. So yeah, that's also dealt with. So I guess the only thing really that's left for us to do is implementing the high score. I mean, currently it can already display a high score. It's just never set. We're still unable to actually set a high score by playing the game. And also we need to make sure that the high score value gets saved when we exit the game and then start it up again. Obviously the high score should not revert to 0 then. So let's implement that now. But first, let's go and do another slight improvement here, because I just realized that what if a player is so good at this game that they actually reach 100,000 points. Currently, this couldn't be displayed in the scoreboard because it only has 5 digits to work with. And yeah, so the highest value it could possibly display would be 99,999. So the player would have no reference or no indication as to what their current score is. The score would obviously go past 99,999, but the player would not be able to correctly see that. So we should fix that by simply not allowing a value higher than 99,999, even though no one's probably ever going to ever reach that value. So yeah, it's not really a problem, but we can take care of it anyway. So let's create a new constant here, an integer constant, and let's call it max score, and set it to 99,999. There, and you can even format that with an underscore so it's easier to read. It's still 99,999. And now, in the setter of the score property, which is currently an auto property, we could implement some logic that prevents the score value to be set to a value larger than the max score. So obviously, if we use an auto property, we can't have any logic in the getter or setter. So we have to convert this to a full property using a backing field. And we can do that manually by simply adding a new field and stuff. Or we could have IntelliSense take care of that by right-clicking the score property and say quick actions and refactorings, and then say convert to full property, which will create a backing field for us and the getter and setter logic. And hold on, there it is. There it is. There's the score field, and I'm going to rename it to underscore score. There. Let me just, yeah, okay. And the getter can stay as it is. We don't need to change the getter. So the getter simply returns the current value of that field. But the setter should prevent the score field to be set to a value higher than this. So let's say, I guess we could simply say there. We could simply use the min method of the math class, which returns the lower value of both values passed. So let's say value is 100,000, then obviously max score being 99,999 is lower, so min returns the lower value, which is 99,999. So that would be correct. There we go. We could also use an if statement to check if the value is greater than blah blah, but we can achieve the same thing with the min method. So now, yeah, if I pass a value greater than 99,999, the score will simply be set to 99,999. And I guess we should also prevent the value from being set to a value less than the 0. Then I guess we can just simply use the, come on. I mean, there. This achieves the same thing. So first we get the smaller value of the 2, and then we get the greater value of 0 and that other value. So let's say someone passes minus 200. The min method would obviously then return minus 200. But the max method would compare 0 to minus 200 and then simply return 0. So then eventually the score field would be set to 0. And yeah, the clamp method in the math helper class does basically the exact same thing. Okay, that should be fine. So now no one should be able to set the score to an invalid value that we're unable to display on the screen. And I guess we can test this by simply going into the T-Rex Runner game class. Let's go into the start game method here and say scoreboard score equals, now let's put it to 99,900. And then just play the game for a while, and then we should see that it doesn't go past 99,999. Why do I have so much trouble saying that? There we go. Obviously that takes a while. There. Perfect. And I guess we don't actually have to remove that, we just have to say 0 instead. So it's actually not a bad idea to set it to 0 in the start game method here. Okay, so let's go ahead and actually implement the high score. And I guess all we really need to do is whenever we run into an obstacle, we need to check if the score that we reached in this run is greater than the current high score, and if so, set the high score to the current score. And I guess the best place to do that would be the T-Rex died method here, this event handler method in the T-Rex Runner game class. So let's go all the way down here and say if scoreboard, and let's go with the display score, because that's what really matters, right? I mean, the score could be 99.76 or something like that, but that doesn't really matter. What matters is the score that is the score as it is displayed on screen. So let's say display score greater than scoreboard high score. Then first of all, I'm going to output the debug message here. New high score set, and then output the display score, and then say scoreboard highscore equals scoreboard display score. There. And that's it. Let me test that. So when we start the game, the high score should not be rendered yet because there is none. And as soon as I run into something, it should set, yeah, there we go. It should set this value, this current score value, as the new high score value. And I'm not sure how it is implemented in the original, if it actually immediately updates the high score, or if it does that after we replay, after we click the replay button. But I think it's okay to do it like this, because I may as well close the game down now, and the high score should still be set at that moment. So yeah, it's fine. So now if I run into something again, coincidentally, it's also 34. Let me... There. Come on. Oh, as you can see, the high score was set to 36. But let me just go for a little value that is a little higher. I don't know. Yeah, that should do. And as you can see, the value is set to 153, and here also the debug console outputs the value. And now if I run into something with my score being lower than 153, the high score doesn't actually get updated. Yeah. But now if I close the game and start it up again, the high score disappears. And we don't want that, obviously. We don't want to only keep track of the high score during one gaming session. We want to save that high score. And yeah, so we actually have to store that high score value on disk. Yeah, so that it gets loaded the next time we start up the game again. And there are a lot of ways we can achieve this. And I think I'm going to go with an approach where we actually create a new class that describes a save state of the game. You could say that is overkill, since it is just one value that we need to store. We could as well, we may as well just write that value in plain text to a file. But there's multiple reasons why I don't want to do that. First of all, if we write the value as plain text to a file, someone could simply just edit that file and set the high score to whatever value. And second of all, I just want to give you an idea of how you could, a general idea of how you could implement a save state for any kind of game, not just this specific game. So what I'm going to do here is I'm going to create a new class. And I guess it's not an entity, so I shouldn't put it in the entities namespace. I'm just going to put it in the same namespace as the game itself. So I'm just going to right-click the T-Rex runner project here, add new item, select class, and then say, let's call it save state. There we go. I'm going to make it public. And it's going to be a very simple class, a POCO class, a plain old C# object. It's not going to do much. I'm going to add a property here of type integer. Name it highscore. And for now, that's it. Maybe I could also store some other values, such as how many times the game has been started, how many times the game has been played. I could do that, or maybe the date and time of the last run, or maybe the date and time of when the high score was set. Yeah, I guess the high score date is actually not a bad idea. I mean, we're not going to display that, but just to show you that, whoops, what did I just do? I just to show you that we can put as much information here as we want, basically. Let's say highscore date to store the date and time when the high score was actually set. Okay, and now what's really important is that we use an attribute on this class that is named serializable, and that marks this class as serializable so that it can be serialized using whatever serializer we want to use. So it puts it in a storable format, and that's it for the save state. As you can see, very, very simple. And now I'm going to go into the T-Rex runner game class, and I'm going to add a new method. And I'm going to call it save game. And what the save game method does, first of all, it creates a new instance of save state. And here I can set the properties. So the high score will be the current high score value of the scoreboard. And the high score date, yeah, I guess we have to store that somewhere. So let's go up here somewhere, here, and add a new field of type datetime. There. And now I can use this field to store the high score date. And I will do that here in the T-Rex died method. Down here, I'm going to simply say, whoops, high score date equals datetime now. So that way I can set the high score date field to the current date and time. And now here in our save game method, I'm going to set the high score date property of the save state to that field value. There we go. And this is called the object initialization syntax. It is semantically identical to doing this. It's exactly the same, and actually the compiler will suggest to use the object initialization syntax instead here. There. It's exactly the same. Okay, now I actually have to save this to the disk, to the hard drive. So let's go ahead and do that. And obviously this could fail. Saving a file can always fail for a variety of reasons. For example, we may not have permission to write to that directory, or I don't know, we run out of disk space, or I don't know. There's multiple reasons why that could fail, so we're going to put that into a try-catch block. There. And so that whenever an exception is thrown, we're going to catch it so that the game doesn't crash. And maybe we can then write the exception message, whoops, into the debug console. Let's say an error occurred while saving the game. And then here output the exception message. And that'll be fine. Now in order to save this, we're going to need an instance of FileStream, which is in the system IO namespace. So we're going to have to add a using directive up here, using system.io, which stands for input output. Now, the FileStream class actually implements the iDisposable interface and the disposable pattern. And what that means is that as soon as we no longer need this FileStream instance, we should always make sure to call the dispose method. So let me just demonstrate this. Yeah, whatever. So what's wrong here? Hey. Oh. There. So let's say we implement the saving logic here now, and then we no longer need the file stream. Then we should always call the dispose method so that it frees up unmanaged resources, like the file handle and stuff. But it is always recommended in that case to not manually call the dispose method like this, but instead use a using block like this. Create there. Oh, I forgot the new operator there. And that makes sure that as soon as the scope of the using block is left, the dispose method will automatically be called. So that makes sure that we don't forget to actually dispose of the file stream instance and free up all the unmanaged resources that were used, like the file handle. And I'm going to move the try catch block in there. Or actually, I could do the other way around. That would be fine as well. There. So let's say we actually do something with the file stream now, blah, 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 and save the file. And then an exception is thrown because we don't have permission to save at that in that specific directory or something. And an exception is thrown. That would mean that the scope of the using block is left, because it jumps into this block here. And that would also trigger the using block to call the dispose method, because its scope is left. So that way we're always safe, and we always make sure that the dispose method is called properly. Yeah, so first of all, we need to define or specify a path where the file should be saved. And if we don't pass a full path here, but just a file name, then it will just assume that the file should be placed within the same directory as the executable. So that's what we're going to do here. And I'm just going to name the file, I don't know, save.dat for save data, something like that. And that's actually put that into a constant, introduce constant there. Let's call it save file name. Okay. And now we need to actually serialize our instance of save state and then write that into the file stream. And we can do that using a binary formatter, which can be found in the system runtime serialization formatters binary namespace. So let's go up here. I may as well use IntelliSense to add the using directive, but there. Make sure to add this using directive. And now I can create an instance of binary formatter. And then I should be able to serialize our instance of save state by passing the file stream here and the object which we want to serialize, and that is the save state. There we go. And that's it. And this way we can save the instance here of save state to the specified file. And yeah, if an exception occurs, then obviously the file will not be saved, but that's still better than if the entire game crashes. And yeah, we catch the exception and just output it to the console. And yeah, that's fine. But we also need to be able to load the save state. So going to add a new method here, load save state. And yeah, basically we want to do the same thing in reverse. So let's see. First of all, we're going to need a binary formatter here. And then we can simply call the deserialize method. But we need a stream for that. And basically we want to do the exact same thing here. So maybe let's copy this here, paste it here. And instead of using the file mode create, we want to open or create. I think open or create is appropriate here. I mean, we could just use open, but if we use open or create, then a save game file will be created the first time that we try to open one. So I guess that's fine. And then here, instead of calling the serialize method, we're going to call the deserialize method, pass the file stream, and it should then return the deserialized instance of save state. But since it could be any type of object, it just returns an object, but we can then simply cast that to an instance of save state. So, whoops, there, and cast this. And I'm going to use the as operator for casting. And here I'm going to say loading. An error occurred while loading the game. There we go. And this should give us the deserialized instance of the save state. Let's say if save state is not null, then set the high score of the scoreboard. Let's also make sure that the scoreboard is actually initialized here. And set the high score date field to, oops, to whatever the property value is of the high score date property. Like this. And that should already achieve exactly what we want to achieve. Now let's see. Now we need to actually call these two methods. So I guess the game should save whenever we set a new high score. So let's go here in the T-Rex died method. And then here, after setting the new high score, we're going to save the game. Maybe format it like this so it stands out. And we also need to load the game, and I guess we can do that here in the load content method at the very end, I guess. Like this. Because that way we make sure that the scoreboard has already been instantiated and initialized. And yeah, that way we should be safe. Let's see, did I forget something? I don't think so. Maybe let's let me open up the folder here where the game is actually in. Bin debug netcore app. And there it is. This is the executable of our game. And now when I first start up the game, it should call this load save state method. And here, since it uses the open or create file mode, it should create a new file called save.dat and then deserialize it as an instance of save state, which will be completely empty, or it will simply fail. But we should be able to see that new file as soon as I run the game. So let's see. There we go. Let's go into the folder. Oh, there it is. I don't know what this icon is. I guess the .dat extension, the file extension, is associated with a certain program that I have installed on my machine. But yeah, apparently it did successfully create the save game or the save state file here. So that's great. So now let's actually play the game. And let's set a high score that, let's say, a high score greater than 100. There we go. Let's run into something here. There we go. And we just set a new high score. And I don't see an error log here in the output window, so I guess everything worked out fine. And so maybe let's close the game and run it again. And there we go. There's the high score. It was saved between the two game sessions. Perfect. Let's try to set a new high score and see if it still works and if it overrides the existing one. Yeah, that's fine. Let's run into something here. There we go. It set the high score to 178. Let's close the game, run it again, and the high score should still be 178. There it is. Perfect. And let me just prove to you that it also sets the high score date by simply, where is it? Yeah, I can simply go here and add a breakpoint here, run the game, and the breakpoint should immediately be hit. There we go. There. And as you can see here in the debugger, I do have an instance of save state here, and there is the high score date and the high score value itself. Perfect. Let me remove the breakpoint. And I think we're done. There's nothing more that I can think of that we can do here. Maybe we could change the icon of the game and also maybe adjust the title of the game as it is displayed here. But those are just minor things, minor optimizations. In general, I would say we're done. We pretty much came very close to the original game. And yeah, it's a fully functioning game. Congratulations to ourselves. So at this point, we're generally done recreating the T-Rex Runner game from Google Chrome. So if you made it all the way to this episode, congratulations. You created an entire fully functioning game from scratch using only the MonoGame framework and your own coding skills. So thank you so much for watching. But wait, there's more. I've got one final episode in store for you, so stick around if you'd like to join me when I take a look at things like the possibility to scale up the game window to double the size by a simple button press, setting up a custom icon for the game's executable, changing the window title of the game, and things of that nature. So I hope to see you around, and bye-bye.